Good morning to everyone. I am Dr. Sumi MS. The topic of my today's presentation is Shifters from Unit 4 Interconnect Memory Architecture and Arithmetic Circuits. On completion, the students will be able to differentiate between barrel shifter and logarithmic shifter. A shift register is a type of digital circuit using a cascade of flip-flops where the output of one flip-flop is connected to the input of the next. They share a single clock signal which causes the data stored in the system to shift from one location to the other. Barrel shifter. A barrel shifter is a digital circuit that can shift a data word by a specified number of bits in one clock cycle. It can be implemented as a sequence of multiplexers, and in such an implementation, the output of one multiplexer is connected to the input of the next multiplexer in a way that they depends on the shift distance. For example, let's take a 4-bit barrel shifter with inputs A, B, C and D. The shifter can cycle the order of the bits A, B, C, D as D, A, B, C, C, D, A, B or B, C, D, A. In this case, no bits are lost. That is, it can shift all of the outputs up to 3 positions to the right, thus make any cyclic combination of A, B, C and D. The barrel shifter has a variety of applications, including being a useful component in microprocessors along with the arithmetic logic units. The output here for this 8x4 barrel shifter is given as Y0, Y1, Y2 and Y3, and the input is a 8-bit input A0 to A7. Here the shift lines are S0, S1, S2 and S3. A barrel shifter is often implemented as a cascade of parallel 2x1 multiplexers. For a 8-bit barrel shifter, two intermediate signals are used which shifts by 4 and 2 bits or passes the same data based on the values of S of 2 and S of 1 shift lines. This signal is then shifted by another multiplexer which is controlled by the shift line S of 0. A common usage of a barrel shifter is in the hardware implementation of floating point arithmetic. The diagram represents a 4-bit barrel shifter. For a floating point add or subtract operation, it requires shifting the smaller number to the right, increasing its exponent until it matches the exponent of the larger number. This is done by using the barrel shifter to shift the smaller number to the right by the difference in one cycle. If a simpler shifter were being used, shifting by n bit positions would require n clock cycles. Logarithmic shifter. A shifter with a maximum shift width of m consists of a log m to the base 2 stages, where the ith stage either shifts over 2i or passes the data unchanged. Maximum shift value of 7 bits as in the figure. To shift over 5 bits, the first stage is set to the shift mode, the second to the pass mode and the last again to the shift mode. The speed of the logarithmic shifter depends on the shift width, and m-bit shifter requires log m to the base 2 stages. The series connection of pass transistors slows the shifter down for larger shift values. Advantage of logarithmic shifter is more effective for larger shift values in terms of both area as well as speed. So the diagram represents a logarithmic shifter. Quiz questions on shifters. Design the different shifters using CMOS logic. Thank you.